video is going to step us through the logic of loading a two-dimensional array. I want you to recall when loading a one-dimensional array, we used a counter-controlled loop, and the counter variable behaved like subscript and allow us to step through first the 0th element, then the first and the second, etc., and input or process that element of each array sequentially. Well, with a two-dimensional array, we have two subscripts. So we have declared here an array called matrix that will hold integer data. And the first subscript is the number of rows, and the second is the number of columns. So we have 3 rows and 4 columns. Now what the logic is going to be for this is we're going to hold row at 0. If you recall, arrays are 0 base. So this will be row 0, this will be row 1 and row 2. Column 0, column 1, column 2, column 3. Recall how we kept doing size -1 with one-dimensional arrays? Similar with two-dimensional arrays. So we're going to hold row at 0, and we're going to start with column at 0, and we're going to put data into that element. And then we'll increment column to 1, but row still 0, input, increment column to 2, and increment column to 3. Once we get to the last column, then it's time to increment row. But we can't keep column at 3. Whenever we increment the row, we're going to reset the column back to 0. And here we are, row 1, column 0, and repeat the process through. Getting to the last column in this row increments row again. Repeating through all the columns. When you get at the very last element, the last row and the last column, the algorithm ends. So for this algorithm, we're going to have two subscripts. Makes sense to me to call it row and column. That way, when I'm reading the code, I can figure out what's going on. So row will be initialized to 0 in the for loop. And then we'll go into the next statement where column is initialized to 0 in that for loop. Then we're going to show to the user, enter the next number. And let's say the key in 7. So where are we going to put that 7 at? Well, we're going to put it in the matrix at row 0 and column 0, which is right here. So 7 will be keyed in right there. Well, we're at the end of this N4, and we will then go back up to the inner for. And if you recall, if you don't have a step here, we automatically step by 1. So the column variable will be incremented by 1. And we test, is that exceeding 3? And the answer is no, it doesn't exceed 3. So we show the user to enter the next number. Let's say they key in 9. Where is that going to go at? Matrix at 0, 1. So 9 will go right here. And then at the end for, looping back up, incrementing column, testing, going back into the loop. Let's say they key in 3. So that's going to go at matrix at 0, 2. Here's row 0, column 0, 1, 2. So 3 will be keyed in there. Looping back up, column is incremented again. And the test is happening. Now recall, as long as you don't exceed the final value, you go into the loop. So 3 does not exceed 3 going into the loop. Let's say the user keyed in 10. Well, that's going to go in row 0, column 3, row 0, column 3, we'll have a 10. Then we'll loop back up, incrementing. Yes, it does increment again. And this time 4 exceeds 3, so we're done with this loop. When we're done with this loop, we go to the next statement after this N4, which is this N4. That causes us to loop back up to the outer loop and incrementing now row instead of column. So at this very state, before we go down to this statement, we're at row 1, column 4. However, when we go down to this statement, since we're not coming from the N4, we're coming from above, this loop starts all over again. And I'll get my eraser. And we're back to 0 with column again. Okay, back to 0 again with column. And we'll have them enter the next number. Say 2 is entered. That's going to go into matrix. Row 1, column 0 is going to have 2. And we'll then go to this N4, looping back up. Column gets incremented. And let's say they enter